So, hello everybody, and very welcome, and thank you for being here. So, today's presentation will be about composite production using a held double belt press, and the focus will be on Tepex organo sheets from bond laminates. So, first, let me introduce us. Here we have Dr. Dirk Bonefeld. He heads up the product management and marketing at Bond Laminates. My name is Christian Kesterke, and I'm working in the sales department of Health. So our presentation will be split into two parts. First, I will give you an overview about hot pressing and the double belt press technology, and then Dirk will talk about organo sheets and the Tepex production. So allow me to give you a short company profile overview from Health. So we are specialized on the isobaric double belt press technology and provide all services related to them, like after sales, maintenance, commissioning, and spare parts. Furthermore, we provide steel belts for double belt presses, and we maintain a fully equipped technology park with two double belt presses. These two machines can be used from our customers for material qualifications, sample runs, and also for productions. We are located in a small village south of Stuttgart, 100 kilometers approximately. We have 80 employees, and we are happy and proud to celebrate our 75th anniversary this year. Okay, what means hot pressing? So in our division, it means a treatment through temperature, pressure, and time. To make it a little bit with a visualization, so we have materials, they run into a hot pressing machine, and hot, temperature, pressure, and time are applied. Most commonly, also a cooling process, also under pressure, will follow to the hot pressing, and you will get a new material or a material with new enhanced properties. So this leads us directly to the next question: why hot pressing? So hot pressing is used for the consolidation or lamination of materials. It will reduce material defects, improves the uniformity, surface quality, and strength. These are just a few examples, and there are many more for reasons for hot pressing. On this slide, we see through common types of hot press machines. First, we have a calendar press. So it works on an Isocoric principle. Here, the material is fed through two heated rollers. We have a very short press time. It's a line pressing. The next is a static press. It also works on Isocoric. Here we have variable temperatures, and this is surface pressing. Important to know, here we don't have a continuous process, it's a stop and go process. Means the material goes in, pressing starts, when it finished, the material goes out, new material in. Finally, the double belt press, as an example also from Health. So double belt presses are available with Isocoric or isobaric pressure. We have variable temperatures, inclusive temperature zones, like cooling and heating. It's a continuous process, and it's also surface pressing. So if we compare these three types of machines in regard to flexibility and output rate, it shows following. It's a calendar press. The flexibility is very low because we have only one fixed temperature and only a line pressing, very short press time. The output rate is quite high because it's fast and a continuous process. Exactly the opposite with the static press. High flexibility due to variable temperatures during the process, but a low output rate because it's a stop and go. It takes a long time to heat it up and cool it down and move it out the material. Yeah. Finally, the double belt press is a combination of both. We have a high process flexibility, many different temperature settings are possible, and we have a high output rate because it's a continuous process. So this allows me to say in regard to flexibility and output, the double belt press will be the best choice. So on this picture you can see a typical held press line with the unwinding equipment in the front, then the double belt press itself and the rewinding equipment at the end. So the unwinding and rewinding can be combined or replaced by many other applications like scattering units, cutting units, or also stacking units. So the process is very variable. You can produce from roll to roll, from roll to sheet. You can from powder to sheet. Many applications are possible. Some key features of the held double belt press. So the machine can be heated up to 400 degrees C and cooled down to 20 degrees C. This enables the possibility to define very accurate temperature profiles for many different materials. So we have an isobaric pressure up to 80 bar. 80 bar is the same pressure you have around 800 meters below sea level, or the same pressure, approximately 160 elephants will apply on 1 square meter. We have pressures in the market with line speeds up to 50 meters per minute and the production width of 2.20 meters, but also other applications or other widths are possible, so talk to us, please. So I mentioned these two terms already several times, isocoric and isobaric, but what does it mean in a press system? On the isocoric press, the constant, the volume is constant, yeah? And the pressure may vary. On the isobaric press, the pressure is constant and the volume may vary. So what does this mean? To make it a little bit more practical, if you have a material with deviations in thickness on the isocoric press, you set the machine to a defined gap. You run in the material and then you will not have the same pressure at each position of the material because the defined gap has not the same influence to the material compared to isobaric press. Here is it like this, the belts are together if there's no material inside the press. If you run material in, the material will press against the belts and you have the same pressure at each point of your material. As a result, you have a better consolidation and densification of your materials on the isobaric side compared to the isocoric presses. Yeah, functional principle of the held double belt press. So you can see the two drums on the inlet and outlet side. The inlet drums are heated and the steel belts are looped around these drums. So it's the same on the top and bottom side. The first part of the machine are the heating zones, separately controllable, and followed by the cooling zones, also separately controllable. In this example, we have 4 heating zones and 2 cooling zones, but this can be different for customers' applications. In the whole area, we have the isobaric pressure cushion. The pressure is created with an oil which pushes against the backside of the belts. And the oil is kept in place with a special sealing system. Yeah, also important to note, so we don't have a pressure interruption between heating and cooling. This is mandatory for the production of many thermoplastic materials, that you don't interrupt the pressure between heating and cooling. How does the process work? So the belts are turning, pressure is applied, and great material like Tepex can be produced. So reasons for a held double belt press. So one could be the high versatility. It's possible to produce many different materials like wovens, non-wovens, films, fabrics, and so on. Multiple treatments like laminating, consolidating, compacting, and smoothing are possible, and also different processes like roll to roll, roll to sheet, powder to sheet, or sheet to sheet are possible as well. So finally, industries and products. So which industries are working with a held double belt press? To make it easy, nearly all. So from automotive over aerospace, furniture, flooring, ballistic materials, energy, electronics, and also construction. In all these industries, many different products like protective vests, helmets, battery materials, fuel cell materials, insulation materials, and organo sheets like Tepex are produced. So at this point, I'd like to hand over to Dirk and say thank you.
Thanks, Christian. Got to understand how this works. So, first, very warm welcome as well from my side. It's a pleasure to see many familiar faces to me here, and it's a pleasure to be on this great stage together with Christian from Held Technologies. And the first thing I want to do now, after I understood, yes, is to briefly introduce into who we are at Bond Laminates. So therefore, some facts and figures, some numbers from our history. We have been founded at 1997 already as a manufacturer of so-called Organo sheets, at that time as a management buyout from the company DuPont. Then the next big milestone, in 2012, we were acquired by Lanxess High Performance Materials, so incorporated in the big polymer manufacturer Lanxess. And now very freshly, just since April of last year, we are part of the Envalior family. So Envalior, I will introduce to you on the next slide. Maybe the name is not yet very familiar to you. Some numbers about our company. We have been working deeply, especially or in particular in automotive projects. So we have been active in more than 200 commercial automotive projects now. Our capacity per year in terms of manufacturing, continuous manufacturing of these so-called organo sheets, or thermoplastic continuous fiber reinforced sheets, is, depending a little bit on the material mix, in the range of 4.5 million square meter per year, which means around about 15,000 production batches we process per year. We have more than 600 material variants through the years, measure a lot of quality data in order to give our customers, which are mainly from automotive industry, the required trust to realize even mass production projects with this, let's say, still new material family. Who is Envalior? Again, a quite new name in the branch. It's the joint venture which has been founded out of DSM Engineering Materials and the Lanxess High Performance Materials. So we are in the field of thermoplastics, I would say quite interesting partner for you. We are offering out of this pyramid of thermoplastics range quite a lot of materials, starting with the technical polymers like polybutylene terephthalate, going via some different nylon grades up to high-performance plastics like PPS and so on. So now let's come to the organo sheets. What is an organo sheet? To make it short, it's a continuous fiber or sometimes long fiber reinforced plastic semi-finished product. So it's a sheet. You can compare it to a metal sheet, but it's based on thermoplastic plastics. And the trick behind is you can heat it up, melt the thermoplastic, bring it into form, back mold it with different thermoplastic compounds, and then realize really in mass production high numbers with a very stable quality, 3D shaped parts for structural purpose, for impact purpose, and so on. So what is important about Tepex and what differs us maybe a little bit from some competing materials is that Tepex is more or less fully consolidated and impregnated. Thus, there are no voids, let's say voids in a range of less than 2% in this material. So it's very compact, and it's really important to get the highly viscous thermoplastic resin very close to the fibers, so you have the perfect adherence between the fibers and the matrix material. Just to give you an idea about the principles of this impregnation and consolidation, what happens, very simplified in this picture, you bring some, let's say, prepregs together, but the plastic is quite far away in the first step from the fiber, from the filament. Then you apply some heat and some pressure, so you melt the polymer, the thermoplastic. Remember, it's very highly viscous. It doesn't want to impregnate the fabrics, and it doesn't want to go into or penetrate the textiles. So you have to apply pressure. The second picture here, what you can see is what happens when you drive the prepregs through a calender or through an isocoric belt press or isocoric press. You still see some voids in between, and you still see that the resin or the melt is not close to the filaments. In order to give the plastic melt the chance to come close, you need a third factor beside pressure and temperature, and this factor is time. Thus, you cannot just roll it through high speed through a calender where, as Christian mentioned, you have just a line pressure distribution, but you have to give it a certain time under pressure and under temperature. And this is exactly what happens when you're utilizing an isobaric double belt press. Why is it important to get rid of these voids and of these inclusions, and in particular to bring the melt to the filament? You will see when you don't have this full consolidation, huge drop in the mechanical performance. I would say the tensile strength and the flexural strength drop is maybe still acceptable, but especially in terms of fatigue and especially in terms of shear strength, you will have a huge drop if you don't consolidate the material in the best possible way. And now we come to the point, why do this on a double belt press? I mean, it's a huge machine, and it's very complicated and high invest and so on. Why don't we do it just in a mold? So in a mold, you anyway have to apply pressure to form a part, shape a 3D part. So why don't use a prepreg, but a fully consolidated organo sheet? It's quite simple. First, you need this uniformly pressure distribution to come close to the filament, which you only need, of course, if you're using prepregs. When you're using organo sheets, the resin is already in the fiber and at the filament surface. So this is the first thing. You need a uniform pressure distribution, and you need a certain time. On the right side, you see a simulation which has been conducted out with this very simple, let's say, structure here. And there's a pressure distribution, of course, not really uniformly, because in the plane, in the XY plane, you have a well pressure distribution. But when you go to this deep drawn, steeper sidewalls, you have a very, let's say, ununiform and maybe not sufficient pressure distribution there. And if you want to reach a full consolidation, which is here maybe a little small numbers, is indicated by the 1, so 100% consolidation, you need in the mold about 5 minutes to reach this full consolidation. And this is in an industrial scale, I would say not possible. With the organo sheets, which are fully pre-consolidated, so the resin is everywhere distributed and it's a compact material, we always target to a cycle time for the part manufacturing of 1 minute, maybe 2 minutes. So this is the reason why we are using this kind of very customized and very complicated double bed presses. And of course, for us, it's a major aspect that we have a huge output and a super stable quality, as these machines are really fully continuous. They don't stop, they don't open or close, but these machines produce a super stable quality for shifts, for days, for week, without stopping them, more or less. One example of what can be done out of the Organo sheets, you will see, or you can have the chance to see and touch and feel at our booth. This is the example of a load compartment well, which is in series in the Mercedes C-Class. I think since 1.5 years roundabout. The predecessor was already in the Mercedes S-Class. You can see this trunk well here, and it hosts the start-stop battery of this vehicle. And the idea behind this idea is to replace a steel well, which would be around about 30% heavier in weight. And this is a semi-structural part. In the case of a crash, it would have to contain all these liquids, could be coming out of the battery. On the other side, prevent media to come into this well, and so on. And as I mentioned, compared to a steel well, we achieved here a weight saving of around 30% with more or less the same boundary conditions, like same system pricing and shorter cycle times. This material is a polypropylene with some continuous glass fiber woven fabrics inside. Thus, this can be 100% recycled, can be shredded, can be compounded, and then processed further to a high performance, let's say, injection molding compound. If I made you a little curious about further applications and possibilities you will have with Tepex Organo sheets, I would like to invite you to our booth on the opposite side of this show, Hall 5, the booth C44. It's close to the Natural Fibers Village. We will show you there some further applications, some solutions for EV battery housings, which are quite challenging, honestly, in terms of the protection of thermal runaway cases. And we are very happy now, since we are in Valio, we have a new family member, which is called Udea, and Udea is unidirectional carbon and glass fiber thermoplastic tapes, which also will be shown to you at our booth. Now I may hand over briefly to Christian again, and I say thank you for your patience. I hope we will have some further discussions after this lecture, and I remain, of course, for your disposal. Thanks.
Thank you, Dirk. So it was very impressive to also for me to learn how our press is used in the market, and together with our birthday this year, we will also show or celebrate the birth of our new machine generation. So the prototype or the first machine of this generation is called Haley. And this new machine will impress with lower production costs, improved servicing, easy accessibility, and predictive maintenance planning, and a completely new HMI for easy operations with many data. And it would be great to see you on our Health Days, which will take place end of September. You can come to our booth, and or directly after the presentation, we can also meet outside directly on the right side and discuss further. So thank you very much.